Encouraged by the success of installing interior lighting into some of my coaches, I thought for my next project I would try to fit some exterior lights to my Lima Class 33 diesel. Before we start, I don't use DCC on my layout, so all the electrical notes in this video apply to old school 12 volt DC. I should perhaps also point out that I've never done anything like this before, and I'm certainly no electrician, so it could all go horribly wrong. I want the loco to have one white LED and one red LED at each end. The left hand light, looking at the front of the loco, will be white, and the right hand one red. Also, I want the lights to change when the loco changes direction. When the loco is running forwards, the white light at the front will be on, and the red light at the rear will also be on. When the loco reverses, the opposite lights will come on. I wanted the LEDs to fit snugly in the correct places on the loco cabs, so purchased some 2mm tower LEDs. I purchased 2 packs of 2mm tower LEDs from DCC Concepts, one red and one white, each pack containing 6 LEDs and 6 resistors, which need to be soldered on before testing. For the white lights, I am using proto white LEDs, which according to DCC Concepts are designed to look right for all steam era and early diesels. The packs also include some instructions, wiring diagrams and information about things called ohms. I found all this interesting, informative and also a bit confusing in parts, but that may just be me. However, I feel wiser having read them, so that's a good thing. I don't have a rolling road, so I lashed up a bit of a test facility comprising an old piece of track and an old Hornby controller. With the loco set up on the test track, the direction switch on the controller is moved to its left position and power is applied. The loco moves from right to left, or for my purposes, forwards. This will help in wiring up the LEDs the right way round. The LEDs have 2 conductors, one of which is slightly longer than the other, and this is the positive or anode conductor. Before testing, a 1000 ohm resistor is soldered to the anode conductor. With the controller switch in the left or forward position, the anode is loosely connected to the far rail and the cathode to the near rail. The speed control is gently increased and the LED lights up. With the direction switch in the right or reverse position, when the speed control is gently increased, the LED does not light up. There are no interior cab fittings in this diesel, so to try and avoid any light bleed from the LEDs shining in the cab, the bodies of the LEDs were painted black, leaving only the very ends clear. I did say earlier that I'd not done anything like this before, so please bear with this next bit, as this is now where I get a little confused. When connecting 2 LEDs of different colours in the same circuit, it is apparently necessary to ensure that the circuit is balanced and that the light level is also in balance. I think this may be so that both colours shine with the same brightness, but I'm not sure. I'm equally not sure that on this loco it will be important anyway, as there will only be one light at each end lit at any one time. However, I purchased some 3000 ohm resistors and then spent some time doing some simple testing. One white and one red LED were each fitted with a 1000 ohm resistor, and one white and one red were each fitted with a 3000 ohm resistor. Various combinations of white and red were then tested and judged by eye to see which I preferred. I wasn't sure what outcome to expect, but I guess it was really no surprise that the most balanced result was with a 3000 ohm resistor on the white LED and a 1000 ohm resistor on the red LED, as you may be able to see here. You may also be able to see that I haven't as yet successfully eliminated all the light bleed from the LEDs, so some more black paint will be required. The large Lima weight is glued into the chassis and a piece of white plasticard glued on top of it. Two phosphor bronze strips are glued onto the plasticard, and these will effectively be terminal blocks for the wiring. I had already added extra pickups to the non-powered bogie, so it now picks up current from both rails. Wires pass from this bogie to the motor at the other end of the loco. I will therefore use this end of the loco to pick up current for the LEDs. These wires were then cut in two, the ends bared, and then soldered onto the phosphor bronze strips. The loco is then tested to ensure that current is still reaching the motor bogie. The Lima dummy light lenses have been removed and 2mm holes drilled ready for the LEDs. In this shot, an LED has been temporarily fitted into the left-hand light as we look at it. The fit is okay. The next step is to actually wire up the LEDs onto the loco, but before that I thought it might help to come up with a wiring diagram of what I think I'm going to do. The diagram is looking down on the loco from above. The long red and blue lines represent the track, and cab A is at the left of the diagram. If we look at cab A, the anode of the white LED with its associated resistor is connected to the top red rail, and the anode of the red LED together with its associated resistor is connected to the bottom rail. If we look at the whole diagram, it shows what would happen when the direction switch on the controller is moved to the left. The top rail becomes positive and the loco would move from right to left. Now, current only lights up LEDs when it flows through the anode in a positive direction. So in this example, it's represented by the red lines, and we can see that the white LED at the front of the loco is on, and the red LED at the rear of the loco is also on. The other LEDs are off. if we turn the whole sheet around so that cab B is now at the left of the picture, we can see that the wiring plan is exactly the same as the other end. So if we reverse the direction switch on the controller, then the other LEDs light up. I hope that explanation was clear. I thought it would be easier to show the wiring diagram on a piece of paper, as once it's installed in the loco it might be more difficult to follow. Now that the wiring is finished, it certainly is more difficult to follow, and it's probably not a good idea to inspect it too closely. But part of the reason it looks so messy is that there are a lot of soldered joints which have needed to be covered with shrink tubing to avoid them shorting out. The wiring diagram was, however, a great help in ensuring all the wires ended up in the right places, and more importantly, that once everything was soldered together, that the lights actually work in the way they were intended. And they do. All that remains to be done now is to fit the LEDs into the cab ends. With the loco on the layout, the controller is slowly advanced and the white LED is illuminated. It can be held on until more power is applied and the loco moves forwards. Similarly, in reverse, the red LED also lights up before there is enough power to move the loco. There now follows a series of shots showing how bright the LEDs look in a variety of lighting situations. Firstly, with my video lights on, then gradually with less lights on, until finally 2 shots in almost complete darkness. A couple of points strike me. Firstly, I think in most of the shots the LEDs, particularly the white one, look a little bright. Running lights on real diesels back in the 1960s and 70s were pretty dim and certainly very difficult to see in daylight. It is only relatively recently that the really bright white lights appeared, and certainly not in the time period I am modelling. I think next time I will try larger resistors to dim them even further. Secondly, the final shots in the almost pitch darkness of my garage show the value of painting the rears of the LEDs black. There doesn't appear to be any light bleed at all, so it was well worth doing. I think for a first attempt at directional lighting, this project has turned out really well. Now to install interior lights into some Mark I coaches for this diesel to pull. So that's all for now. See you next time.